Okay, so unfortunately for class 4, we weren't able to get the video of the class, so I'm just going to be making like a quick video just to explain what we covered in the class. So if you want to like review it or like if you missed the class, then you can just watch this video right now. Okay, so this is lesson 4 of the 4th week. Let's start. So today's topic, or today's class is mainly going to be on header files. And yeah, we are going to, like the class did cover some other stuff as well. So what are header files? Header file is a file that ends with .h or .hpp, and this usually contains declaration of functions, classes, all that stuff. So if you think back to how like in C++, if you define like a C++ file, you have the .cpp, or header file, you have to do a .h or .hpp. It doesn't usually contain the implementation of functions, but rather their prototypes. And I'll explain what this means in a sec. So you guys might not know what functions are yet because we haven't really covered that, but you should know what variables are. Yeah. So just to explain what I mean. Now you don't have to understand this yet because I'm just doing like a brief like explanation right now. Okay. So let's say this is our main. This is gonna be our main file. That's main.cpp. We have this function add12. Now, as you can see, like the function isn't actually in here. Like we just have this add function, but it's not in the file. What we did is that we created this header file, and first we define the function. Now, I'll just give like a brief summary of functions. Functions are basically, if you have had Python before, you basically have to declare the return type. Now the function has to return a value. That's what functions are for. When you use a function, you want it to return something. So in this case, it's going to return a plus b. That's going to be an integer. So you just want to create this function here, and you can name it whatever you want. And then in like these brackets, you want to use the variables. So what variables are you going to pass into the function? And you also have to declare the type. So if you want to pass in two numbers, well, you can have integer a, integer b. And then what you want to return is a plus b. So return is basically what value you want to get from this function. And yeah, so this is the header file, of course. As I said before, the header file doesn't typically contain the implementation of functions. So I can see I just defined this in this header file, I just defined the function here. I didn't actually say what it does. And so this is just like a prototype of it. But in here, I said include test.h, and I actually explain what it does. So now if I say I include test.h, you can add it. So that was just a quick summary. Like I'm obviously gonna get more in depth in here because that was just like a brief overview. So what are the purpose of header files? As I see, like technically what we could have done, we could have just done this. Like without header files, like ignoring all this, we could have just done. We could have just removed this and this would have been normal. Like this is a function, which we will learn more about in future classes. You don't really have to know what that means right now. We just add it and then just output it something like we don't even need these two other things. But just for the sake of this, we do actually need it. Purpose. So that's declaration chain. It allows you to declare a function and use them across multiple source files. So this will help you in avoiding code duplication. So pretty much what I have to do for each file I want to make, like if I want to make like another file .cpp, and I want to use the add function. Like I want to use this function. Well, with header files, you can just say include, like I'll just include test.h, because this header file, this will contain the information of the function. So I just use it like, okay, sorry, my bad. Yeah, just include this, and I can just use this function here, like in this head file. This is just a prototype of it, and then in here I have what it actually does, so I can just like, I can use it. I don't have to rewrite it again. Like I don't have to like put this here and then do it like copy and paste it here just to use it. Like if I have like a million other files, I can just use this line. I'll have access to that function. code organization, of course. It makes, code base more organized, especially for bigger projects. You don't want to have a lot of code duplication. Like that's going to be a bunch of extra code that you do not need for bigger projects. Encapsulation, of course, like as I mentioned before, it'd be so much easier to just like for a file, you don't have to like put all this line of code. Like you don't have to use up this space. It's just much easier to use heavy files. Yeah, and also in the implementation files, you don't need to change like, okay, here's what I mean. So let's say you want to change how this works. Okay, like you don't have to change anything in the main.cpp. Like if you have a million files that all use the same function, you don't have to go and change every single function. All you have to do is go to the header file, and then this is just a prototype, go to its implementation, and just change this. Like, let's say I want to do times b times 5. And now I can use this program. I didn't have to change anything in here. All I had to do was just change like one thing in here. And that's how it works. So if I add 1 and 2, this isn't going to be 3 anymore. It's going to be 1 plus 2 times 5. That's going to be 11. So if I run it, 11, see? Yeah, I just changed it here. And then I didn't have to change anything here. So this is just an example, which I already covered. Feel free to try this out for yourself. It can be a bit confusing at first, but you just gotta keep practicing. That's how it works. Recap what are the 4 items that encapsulate the purpose of header files. It is sharing, organization, encapsulation, efficiency, all that. Scope. Now, scope is something very important if you're going to be using this a lot. Well, not using it, just a concept. So, a scope refers to a region of a code where a name can be accessed by other variables or other things in the same scope. And these are determined by the curly brackets, which you have probably seen already. Well, there are many types of scopes here, like there's 7 here, but to be honest, just don't worry about them. All you need to know is that scopes exist, and in these curly brackets, that's where different like variables can interact with each other. Like that is a single scope. So what I mean is that in this here, let's say I was to create like, you see these curly brackets. This defines a scope. So if I were to put like a variable here, AB, I said int a equals 5. Well, I've declared this variable in the scope, and in this scope, I can use this variable. Or you can declare globally. Like if you declare like some at the top, let's say int a equals 5, you have declared the variable globally. That means any scope can use this. So like this is globally declared. So even if I have like this is its own scope, I can still use this because I declared it globally at the top. Yeah, I got 5. What? Yeah, my bad. No, I meant to type A because obviously if I just put 5, it won't work. But yeah, 5. See. All right, while loops. So while loop is a type of loop that will repeatedly execute the condition until this condition becomes false. So pretty much what this means, this is while condition. So that means while this condition is true, execute whatever code is in this scope. Yep, so just again, as I said, if it evaluates the true, it will execute the code, and it's going to keep executing that until the condition becomes false. And if it's false initially, it'll just skip over that. Code block, this is what you want to execute in that while loop. So I just mentioned that before. So here's an example. I can just code this up because just to show you guys. Okay, so let's say and while I is less than 5. So I'm declaring something here, like while this variable is less than 5, I'm going to do something. I'm going to first declare check what the value of the variable is, and then I'm going to increment it by 1. So what's going to happen here is, I'll just run it and see how. Okay, this is exactly what I expected. Okay, so you execute the code. What happens is you declare the variable, and then you enter this while loop. So initially the value of I is 0, and is I less than 5? Is 0 less than 5? Yes. So you output 0. And then I plus plus. What this plus means is that you increase the value, increase the variable by 1. That's what plus plus means. If you do I minus minus, means decrease it by 1. So you know. So okay, I becomes 1. You go back here, and you pretty much just repeat this until something changes. So I is 1. And then I is 1, so 1 is still less than 5. So you just output this again, so you get 1 here. And then you increase the variable by 1, so now the variable was 1, now it's 2. And you go back here, go back all the way to the start, and you check, is I less than 5? Well, I is equal to 2, that's less than 5. So again, you output it here, and you just do pretty much the same thing until you get to 4. So I now has become 4, it's entering this loop, and it says 4 is less than 5. So you output 4, and then you increase 4 by 1. So now the variable is 5. And you go back here, and you set, and the condition to execute this is that I has to be less than 5. Well, I is equal to 5 right now. I is equal to 5. I is not less than 5. It's equal, it's not less. So that means, well, that's false now, so this doesn't run, and then the program ends because there's nothing left. And that's why I output 0, 1, 2, 3. Infinite loops, just be careful of these infinite loops because if sometimes you have a program where like you're going to be stuck in here forever, basically. So this is just an example. Let's say, okay, and if you have an infinite loop, your program can just crash, your computer can just freeze. That's pretty much what happens. So let's say while, well, this is a popular example, while true. Now, what do you think is going to happen? It says, so while loops keep executing until this condition becomes false. Well, true is always going to be true. True is always going to be true. There's nothing that's never going to become false. So if you run this program, which I'm just not going to do because I just don't want to, because it'll probably like break the program or something. But I is equal to 1, and while true, you execute this, and it's going to keep executing 0. This is while true. This is always going to be true. You're going to be stuck in here forever. I is always going to be 0. It's always like, this is always going to be true. It's never going to be false. So you just keep outputting zeros pretty much until your computer crashes. Now we have for loops. This is probably more popular than while loops. A for loop is a control flow statement that allows code to be executed repeatedly based on a condition. And you wouldn't know the number of iterations before entering the loop. So I think this makes for loops more convenient than while loops. You have the condition of the code block. Sort of the same as while loops. Valid condition, true, false. Okay, now I'll just use an example. Okay. So pretty much to summarize what the slides were saying here. Summarize what the slides are saying here. So, and this is the neat thing about for loops. You don't have to declare a variable like that initially at the top. You just declare in the for loop. So first, let's see the steps again. Well, okay, initialization, condition check, increment, code block, pretty much. So initialize your variable. I'll name it I, and I'll just initialize it to 0. So what's my condition? I'll say I is less than 10. So this loop will keep executing until while I is less than 10. And then I will increment it. So I'll increment it by 1 each time. And then up. And now I'll just print out I. Okay, now this is what you would expect, right? I is less than 0, so you keep printing out the value of I, and you remain in the for loop by incrementing I with a variable 1 each time. So like initially it's 0, 0 is less than 10, so you output 0. You increment that by 1, so now it becomes 1. And 1 is still less than 10, so you keep doing that. Until you reach 9, you output 9, you increase by 1, that's 10. 10 is not less than 10, 10 is equal to 10, so you break out of here and it stops. Now usually like you won't have an infinite loop in a for loop unless it's intentional. That's pretty much what will happen. So you still can get an infinite loop in for loops, and this is how it happens. Okay, so I think you might be able to see why this is never going to end. So I is less than 0. Okay, you output I, you output 0, just like here before. But this time you decrease it by 1 each time. So I is going to become -1. You output -1. As you become -2, you can output -2. And you can keep doing that until infinity because I is always going to be less than 10. If you keep decreasing it, then obviously I is never going to get past 10. It's always going to be below. This condition will always be satisfied. So it's going to keep like I is going to keep getting lower and lower and lower. And it's never going to ever be close to satisfying this, or not satisfying this condition. Like this code will run as long as I is less than 10. And if you keep decreasing I, well, obviously no negative is going to be greater than 10. So try this problem. All right, program language for our choice for a while 100 times. Well, your choice. So you can use for while loops or for loops, and print C++ is crazy 100 times. And this is the solution. If you want to test it out yourself, just click back and just try working out. And the code doesn't have to look exactly like this, but these generally are the solutions. You can use a while loop, for loop. Both loops have their own time and place to use. In this example, you declare I to 0, and while I is less than 100, you see out this, and you increment I by 1 to avoid infinite loops. And eventually, I is going to be 100, and that's not going to be less than 100, that's going to be equal to 100. So at that time, you print it out 100 times. This is pretty much the same thing. It's just that in the for loop, you move this, and you move this into the brackets, or yeah, and then you see out this. Yeah, that was just a brief overview of what happened because we forgot to record the class. Or well, we did record the class, but there was an issue with that, so